In this video, we'll turn our attention to finding intercepts of the graph of functions. While we haven't actually graphed a function, we are building to that process. And we did do some graphing in an earlier section. And just recall that we studied two key points of graphs, that is the x-intercept and the y-intercept. The x-intercept, if you recall, corresponds to a point of the form x comma 0, right? The x-intercept is the place where the graph crosses the x-axis. The y-intercept corresponds to a point of the form 0, y, where y is some real number. To find intercepts of the graph of functions, well, just recall that y equals f of x. So when we're talking about letting x equal 0 or letting y equal 0, we can do that in this function notation. So we'll start with to find the x-intercepts. So remember that if we had an equation in the form y equals something, to find the x-intercept, we would let y equal 0 and solve for x. So in our function notation, f of x is what is representing y, so when we say let y equal 0, we're actually setting f of x equal to 0. That will be some equation that we're going to solve, and then the x values that are solutions to that equation become the x-coordinates of the x-intercepts, right? So the order pair x0 is an x-intercept of the graph of f if x is a real solution of f of x equals 0. The y-intercept, remember the y-intercept, we said we want to let x equal 0 and solve for y. So in this function notation, y equals f of x, when we let x equal 0, we're really going to find f of 0. And f of 0 is some y value. So the y-intercept of the graph of f is the ordered pair 0, f of 0. Sounds complicated. It really is applying the things that we've already learned, just using function notation. So let's do a couple of examples. We want to find the x and y intercepts of the graph of each function. First one is f of x equals 3x plus 7. So this is a linear function, which we'll actually define soon, but a linear equation in two variables. So if we wanted to find the x-intercept, remember x-intercept, we let y equal 0, but in function notation, that's going to mean we're going to let f of x equal 0. So we would have 0 equals 3x plus 7, and then subtract 7 to get negative 7 equals 3x, and then divide by 3 to get negative 7/3 equals x. Therefore, the x-intercept is the ordered pair negative 7/3, 0. The y-intercept, we want to let x equal 0, but in function notation, that means to find f of 0. So f of 0 is equal to 3 times 0 plus 7, or 0 plus 7, which is 7. Therefore, the y-intercept would be 0, 7. So if that notation confuses you, really just write that as y equals 3x plus 7, then let x equal 0, solve for y, let y equal 0, solve for x to get the intercepts. Part B, we have f of x equals the square root of x plus 9. To find the x-intercept, again, we want to let y equal 0, which is the same thing as letting f of x equal 0. So we will set the function, the square root of x plus 9, equal to 0 and solve. We can do that by squaring, since that is a square root equation. To eliminate the square root, we square to get just x plus 9 on the left equals 0. Subtract 9 to get x equals negative 9. The x-intercept then is negative 9, 0. The y-intercept, find f of 0. F of 0 is equal to the square root of 0 plus 9, which is the square root of 9, or 3. So f of 0 equals 3 corresponds to the ordered pair 0, 3.